My name is Pat Griffin, and I'm here to introduce you to basic physics. The first concept you have to understand in order to do physics is the concept of mass. Mass is a measurement of all the matter in an object. It's measured in kilograms. Now, everything you can see, feel, or touch has mass. This blackboard, I have mass, and this apple has mass. Mass can be affected by forces, and it's the basic concept you have to understand in order to do physics. The second concept, which is inherent to your understanding of physics, is the concept of acceleration. Acceleration is the change in velocity over time, so that's meters per second per second. A good example of this is the force caused by gravity on an object. When I drop this apple, it's gonna accelerate at 9.81 meters per second squared, which means it's gonna gain speed at that rate over time and eventually hit the ground. Acceleration. The third concept, which you have to understand in order to do physics, is a little more complicated than the other two. You're going to take those two, which is mass times acceleration, and you get force. Force is measured in newtons, and I just happen to have an apple here, which is 1 newton. So when I drop this apple, it's going to accelerate at 9.81 meters per second squared, and it's going to multiply that times its mass in order to hit the ground with 1 newton. That's going to be the force that this apple has while accelerating. One more thing that you have to know in order to do physics is the concept of equilibrium. Now, everything can have equilibrium. In fact, I have equilibrium right now. I'm standing still, which means all the forces on me are equivalent. I have a normal force from the ground, which is pushing my weight up, which is the opposite of gravity pushing me down to the ground. So at this time, the two forces are equal, which means nothing is happening, and I'm standing still. That is static equilibrium. Kinetic equilibrium happens in another way, where your forces are still equal. If I decide to walk at a constant velocity, it means that the forces up and below me are going to be the same, but there's also going to be friction opposing me and my force pushing forward, which means that, again, the forces will be equal and I will have equilibrium. That's called kinetic equilibrium. Static is when you're standing still and you still have everything is equal. And kinetic is when you're moving and all the forces are equal.
I will now teach you about a few laws of motion. Its first law is that an object at rest will stay at rest, and an object in motion will stay in motion unless it is acted upon by an outside, non-zero net force. For example, this ball is at rest. However, if I kick it, it will accelerate in the direction of the force. Now it's time for Newton's second law. Newton's second law states that the stronger the force, the faster the object will accelerate. It also states that the heavier the object, the less it will accelerate. For example, if I kick this ball harder, it will accelerate faster. Now, if I kick each of these balls with the same force, the lighter ball will have a much greater acceleration. Newton's third law states that for a reaction, there is an equal and opposite reaction. If I punch this wall, I'm applying a force onto the wall. It is also applying a force on my fist. This is the reaction force. You will now learn about the special forces. The first of the special forces is weight. It is also known as the force due to gravity. Gravity always acts downwards towards the center of the earth. Now, you may ask, what's keeping me from moving to the center of the earth? Well, this is the normal force. The normal force acts perpendicular to the surface that the weight is on. The next special force is tension. Tension is a force that acts upon objects such as strings and ropes. If I apply this downward force on this string, tension will act this way along the string. Have you ever wondered why a car or a bike eventually rolls to a stop? This is because of our fourth special force called friction. Friction is a force that acts in the opposite direction of motion, which eventually causes the
Let's
object to
consider
slow down.
these three materials. We have the medicine ball, the floor, and the carpet. The medicine ball against the floor has a much lower coefficient of friction than the medicine ball against the carpet. If we kick the ball on the floor, it will go much farther than when kicked on the carpet.